The universe is full of questions, some vast, some small, but all profound. One such question: can a spider build its web without gravity? For millions of years, spiders have relied on gravity to anchor their intricate traps, but what happens when you take that force away? NASA set out to solve this aboard the International Space Station. The goal: to see how much of a spider's web building is instinct, and how much is shaped by its environment. The ISS became the stage for this unique experiment, starring a few eight-legged astronauts. Understanding how life adapts to microgravity is crucial for our future in space. Every living thing on Earth has evolved under gravity's pull. As we plan for missions to the Moon, Mars, and beyond, we must know how life changes when that pull vanishes. The spider, with its gravity-dependent behavior, was the perfect test subject. Its web is a visible diary of its neurological processes, now being written in orbit. The story of these spacefaring spiders is about more than webs and weightlessness. It's about resilience, adaptation, and the surprises of life. Their journey would prove as tangled and fascinating as the webs they spin. The first attempt to answer our cosmic question began in 2008. Two spiders were sent to the ISS, one as the main subject, the other as backup. They brought fruit flies for food, aiming for a controlled look at web construction in zero gravity. But space had other plans. The backup spider escaped and joined the main habitat, turning the experiment into a competition. Instead of one web, there was a chaotic tangle, impossible to analyze. Meanwhile, the fruit flies multiplied rapidly, their larvae swarming the habitat and blocking camera views. The mission was deemed a failure: unreadable webs, obscured cameras, and no clear answers. Yet, failure in science is rarely wasted. The 2008 experiment taught researchers valuable lessons about habitat design and managing living organisms in orbit. It was a setback, but it paved the way for a more refined, robust second attempt. Sometimes, the most important discoveries come from what goes wrong. The tangled webs and runaway flies set the stage for a better experiment. Science, after all, is about learning from mistakes. The next chapter would be different. In 2011, the team tried again, this time with golden orb spiders, famous for their regular webs. 4 spiders were chosen, 2 for the ISS, 2 as Earth controls. Each spider had its own escape-proof habitat, and every detail was planned to avoid past chaos. But a mix-up: 2 spiders were actually males, not females. By chance, 1 male and 1 female went to space, the others stayed on Earth. This accidental pairing opened new avenues for discovery. The experiment ran smoothly: clear habitats, active spiders, and perfect camera views. On the ISS, Esmeralda and Gladstone spun their webs. On Earth, Florence and Goethe did the same. The cosmic experiment was finally underway. High-resolution images streamed down, showing webs spun in a world with no up or down. The inclusion of male spiders allowed for unexpected comparisons. The stage was set for genuine discovery. This time the spiders would reveal their secrets. On Earth, orb weavers build asymmetrical webs using gravity to their advantage. The hub sits high, the bottom section is larger, perfect for catching prey below. The control spiders on Earth built these classic webs, following their evolutionary blueprint. But in the ISS's microgravity, something remarkable happened. In darkness, the space spiders built nearly perfect symmetrical webs. Hubs centered, spirals radiating evenly. With no gravity, their webs reverted to a pure geometric form. This was the spider's instinctual blueprint, stripped of gravity's influence. The discovery was profound. Web building is flexible, not fixed. The spider adapts its design based on its environment. Gravity isn't required for web building, it's just a tool for optimization. In space, spiders fell back on their fundamental, symmetrical design. This revealed the interplay between instinct and environment. The spider's brain holds an ideal web, but it's also a pragmatic engineer, reshaping that ideal to fit its world. Whether on Earth or in orbit, the spider adapts, showing the power of flexible instinct. The experiment held another surprise. In darkness, space spiders built symmetrical webs, but when a lamp was switched on in their habitat, their webs became asymmetrical again, just like on Earth. The hub shifted away from the light, and spiders oriented themselves with heads pointing away from the lamp. In the absence of gravity, light became their new down. This adaptability was unexpected. On Earth, spiders don't rely on light for orientation. In space, they used light as a compass, remapping their sense of direction. This phenomenon, phototropism, is common in plants, but seeing it in spiders was a revelation. The spider's brains seamlessly switched from gravity to light as their anchor. This flexibility in sensory processing is a powerful survival trait. It suggests that, in the absence of one dominant sense, the brain can prioritize another. For spiders, light became the new anchor in a world without gravity. Life, it seems, is always ready to find a new way to create order from chaos. If you found this as fascinating as we did, smash the like button and subscribe to the channel for more amazing science stories. The webs themselves are only half the story. Spider silk is one of nature's most extraordinary materials, stronger than steel, yet incredibly light and elastic. A garden spider can produce up to 7 types of silk, each with a unique purpose. Silk is tough, elastic, and maintains its properties in extreme temperatures. It's also biodegradable, hypoallergenic, and naturally resistant to bacteria and fungi. Spiders recycle their silk, consuming old webs to reuse the proteins. This closed-loop system is a model of efficiency and sustainability. If we could mass-produce synthetic spider silk, it could revolutionize industries, from body armor to medical sutures. The ISS spiders proved that silk production isn't dependent on gravity. They demonstrated advanced biological manufacturing in space. Nature's technology, spun in orbit, hints at what we might one day build far from Earth. The spider's silk is a marvel on any planet. The journey of the space spiders is a lesson in adaptability. Sent into an alien environment, they didn't just survive, they thrived. When gravity vanished, they recalibrated, using light as their new guide. Their web designs, once thought fixed, proved to be dynamic calculations. This flexibility is the essence of survival, allowing life to flourish in the most unexpected places. The first mission failed, but persistence turned setbacks into success. Science is a cycle of questioning, testing, failing, and trying again. The space spider's story is a microcosm of this journey. They expanded our understanding of how life adapts to new frontiers. As humanity looks to the stars, these lessons are invaluable. The spiders showed us that biology's rulebook is flexible, not fragile. Life is resilient, always finding a way, even when the ground disappears. In the vast universe, creativity and adaptability are our greatest tools.